Hello, my name is Fu Nguyen. I am presenting our tool for IoT deployment called GeneSIS. We want to show how GeneSIS can support for more fine-grained security control for smart IoT system. This work is done together with Nicola Ferri and in collaboration with Angel Rigo Fernandez from Tecnalia. Our work is motivated by the requirements from a smart building scenarios, the cubic smart building of Tecnalia. The IoT platform called Small, developed by Tecnalia, is a IoT platform that can provide the connection between the IoT application and the sensor and actuators in the smart building. So you can see here, for example, the temperatures from the sensor can be sent to the IoT application via the Small platform. On the other hand, the actuation orders can also be sent from the IoT application via the Small platform to the smart building. And here it is important that all the actuation orders must be checked before any order actuation order can be sent to the actuators. We also find the requirements that not only that we need to check the actuation order to be from authenticated stakeholders, but we also need to check exactly which application are allowed to access to which actuators. So the context here is that the smart IoT system, for example, the smart building, they always continuously evolve for better functionalities and with the aim for higher quality and trustworthiness. So we know that smart IoT system, they can be upgraded with new functionalities, new application with new IoT devices together with new functionalities and applications. And all the time, we must ensure the high quality and the trustworthiness of the smart IoT system. For example, the security aspect and privacy aspect. So the question is how to support the continuous deployment of smart IoT system when it's always evolve and need to have corresponding up-to-date security mechanisms. To better show the effects of our demonstration, we use Home.io instead of the real cubic smart building. But here it is has all the sensor and actuators that can be used to demonstrate our support for continuous deployment of smart IoT system with security support. So in our demo example, we use a um, similar architecture of a smart IoT system like the smart building that we have. And in the first version of this smart IoT system, we have a smart application called energy efficiency that can monitor the energy usage in the Home.io and customize the energy usage in the Home.io. So first we start the deployment tool GeneSIS by from the command line, and then we can access to the GeneSIS user interface from the browsers. So using the GeneSIS browser, um, we can add different components. So in the first version of the Home.io smart building example, we have on the right hand side the Home.io simulation that can be connected via MQTT. So the sensor data from Home.io will be sent via MQTT broker and small IoT platform to the application on the app server. And the actuation order can be sent from the application to the via small platform to the actuators in the Home.io simulation. In the evolution of the smart building, there will be new applications can be added. So not only the energy efficiency, but then there will be a new application called user comfort. It has also the connection to the Home.io via the soon IoT platform here. Also in the evolution of the smart building, not only new application can be added, but also new IoT devices and services can be added in the smart IoT system. So now in the smart buildings scenarios, it is very important to have the fine-grained control of which application can access to which IoT resources in the smart building. in the surrounding areas, like air quality sensor or the smart display somewhere else outside of the smart building. So here we have a real requirements for more fine-grained access control. We need to integrate the default support of small security together with, for example, third-party security mechanisms to make more fine-grained access control. So the DevOps team developing the smart buildings, they can consider to add a more fine-grained access control mechanisms. For example, CASBIN that can provide more fine-grained access control for the smart building scenarios here. Authorization library like CASBIN with different kind of access control models can be used here. So here we choose a role by access control implementation of CASBIN in Java, and we specify in the policy that only the user comfort application can change the blind position. So for this demo, we show how different application here can get access to the Home IO. So after implementing the policy decision point using the zcaspin framework, the DevOps team does need to update the security checker of the small framework with the policy enforcement point that not only check for the authenticity of the actuation commands, but also that actuation commands that need to be conformed to the security policy defined in zcaspin. In the Home IO application, we use a simulation scenarios that is inspired from the smart building. So in these scenarios, we will mainly focus on one simple actuators. This is the blind position actuation. So now let's deploy the smart building system that we have specified in this deployment model. So we can trigger the deployment from GeneSIS, um, and then we can see the status of the deployment from sent from GeneSIS here. So we can see that the status of the deployment have been going on, and we can check also to see that the real services have been deployed on the corresponding gateways. We can connect to Home IO via an MQTT interface, so that we can receive the sensor data and control actuators via MQTT topics. Now, with everything has been deployed properly, let's test the policy enforcement for the application here. So let's open the user comfort application. So here we can open the user interface that we can see the sensor data sending from the Home IO application, and we can also open the blinds from here. According to the policy, user comfort application can get access to change the blind in the Home IO. So let's try to open the blind now. Then we see that it can be this actuation command can be executed by the Home IO. If we look into the log of the deployment on that gateway, we can see that the security checker is true for both security token is compliance and it is authorized with the commands to be done from the user comfort application. Let's assume that the smart energy application also try to change the blinds that it should not be allowed to do, and let's send manually from the command lines the values from the smart energy application that want to get access to the blind. But here, the security checker said that the compliance is true, but it is not authorized to change the blind. According to the access control policy, only the user comfort application can get access to the blind.